Hello, all. Let's start part 2 of section, actually 2.2, not 2.1. It's written here 2.1. Mistake, 2.2. More on functions and their graphs. We discussed how to find the maximum, local maximum and minimum of a function. Also, we discussed how to find the symmetric. If a function is symmetry about y-axis, x-axis, an equation is symmetry about x-axis or about origin. Now, a little bit more on functions. Let's talk about even and odd functions. How to know if they give you a function, how you should know if your function is even or odd. Correct? Let's start with even functions. Every time that you have a function of f of x given to you and you want to check that your function is even, replace your x with negative x. Correct? Let me change the color here. Replace your x with negative x. Correct? F, look at this, f, your f of negative x becomes equal to f of x. In this case, your function is even. This is the condition that you have to remember. If f of negative x becomes equal f of x, in this case, your function is what? Even. Correct? Let's do an example to check this. For example number 1, f of x, I will start with very easy one. F of x equal x squared. I don't know. Well, maybe this one, everyone knows that it's even. But if you don't know this function is even or odd, correct? Let's check if this function is even, how I will replace my x with negative x. Okay, then f of negative x equals, look, here you have x, you have to replace it with negative x. Then what I do, I'll put here negative x and I'll square it. Then f of negative x equals, what is negative x squared? Negative x squared gives you back positive x squared. Now, look at the given equation, which is f of x equal x squared, and look at the resulting equation when you replace x with negative x. What do you see? The right side of both equations are the same. Remember this rule from beginner math? If you have two equations, for example, A equal B, and you have another one, for example, let's say C equal B, if the left side of these two equations, if one side of these two equations are equal to each other, it means the other side is also equal to each other, and you can write A equals C. Look at between these two equations. The right f of x equal x squared, your right side is x squared. f of negative x equals x squared, the right side of x squared. Then based on this rule, can I write f of negative x equals f of x? Definitely yes. Look at this. Your f of x becomes equal f of negative x. It means your function is what? Your function is even. To give you an idea why we call these functions even, even functions are always symmetric about y-axis. For example, the graph of this function, everyone knows it's a parabola, right? It's like this. And parabolas are symmetric about what? About y-axis. Correct? Now, another example for even. Let me discuss the odd, then we do few more examples. Now, odd functions. Again, how you should know that a given function, for example, f of x, is odd. The method is totally the same. Again, you are replacing your x with negative x. Same method. Replace your x with negative x. Now, what is the condition? F of negative x becomes equal negative outside of f of x, the negative of the function, then in this case, you can call that function an odd function. If f of negative x equals negative f of x, in this case, your function is what? Odd. Again, let's start with a very easy example. F of x equals x cubed. What should I do to check this function is even or odd? I'll replace x with negative x. It means I'm looking for the f of negative x, correct? F of negative x equals negative x cubed. Then you can say f of negative x equals negative x cubed gives you negative x cubed. Clearly, here you can see that f of negative x equals the negative of your function. Look, here you have x cubed. If you compare these two equations, here you have x cubed. The only difference is that this one doesn't have, the given one doesn't have a negative, but your resulting one has a negative. Then your f of x equals the negative f of x. And you can say, oh, my function is odd. Correct? Please, please don't think this way that, oh, if I have an odd exponent, the function is odd. If I have an even exponent, the function is even. Don't do this mistake, please. Correct? Don't do this mistake because some of them, even the exponent is even, but they are not even functions. Correct? Don't judge a function based on the exponent. Why the professor is explaining this way? Then because I did two easy examples, I'm just looking to the exponent, then I'll say, oh, it's even function or odd function. No, it's not that case. You have to check, right? Let's do some more examples. Example 3, I'll copy it from your book. Determine whether each of the following functions is even, odd, or neither. Sometimes even you have the case of neither. If you don't have those criteria, those two criteria, it means you have to write neither, correct? Okay, the first one, f of x equals x cubed minus 6x. They are telling you to check if this function is even, odd, or neither. The test is you only test once. You don't test like few times because you just replace your x with negative x. What I do, I look here for the f of negative x. F of negative x equals negative x cubed. I'm changing the color constantly here to just show it for you that you are replacing x with negative x minus 6 times negative x. Let's simplify the right side, correct? Then f of negative x equals negative x cubed gives you negative x cubed. Negative times negative gives you positive 6x, correct? Then f of negative x equals, look, if I take negative here as a common, correct? And open a parentheses, negative x cubed divided by negative gives you positive x cubed. Positive 6x divided by negative gives you negative 6x. Now, just compare the right side of the given function with the right side of the resulting function after you replaced x with negative x. What is the difference? The only difference is the outside is a negative, correct? Then can I write f of negative x in this problem equals the negative x cubed minus 6x is actually f of x, right? Negative f of x. Which condition is this? This is the condition that the function is what? Odd. Then easily you find that your function is what? Odd. Let's do more examples. There are at least 3 in this problem. G of x equals x to the power of 4 minus 2x squared. To check if this function is even, odd, or neither, again, I'll replace x with negative x. It means I will look for the g of negative x. G of negative x equals negative x to the power of 4 minus 2 negative x squared. Let's simplify. G of negative x equals negative x to the power of 4. Any negative number to the even power gives you positive, correct? X to the power of 4. Negative x squared gives you positive x squared, then positive x squared, you have a negative here, that gives you back negative 2x squared. Compare the right side of the given function with the right side of the resulting. They are the same, right? Then because g of negative x is actually equal to the g of x, then I can say my function is what? Even. Correct? Let's do one more example, then I'll jump to the next topic. Another example. H of x equals x squared plus 2x plus 1. X squared plus 2x plus 1. What we do, we replace x with what? Negative x. Then you will end up here with negative x squared plus 2 times negative x plus 1. Simplify. H of negative x equals negative x squared gives you positive x squared. Positive times negative gives you negative 2x plus what? 1. Here you cannot do anything more, right? Even if you want to take a negative common, it doesn't mean anything, right? Doesn't mean anything because your first term is not negative. Now, compare the first equation, the given equation, with the resulting equation. They are not the same. You don't have both conditions. Your f of x is not equal to the f of x. F of negative x is not equal to the f of x. You see clearly. Also, f of negative x is not equal to the negative f of x. Then what you write here, you write neither. Correct? What you write here, you write neither. This function is not odd. This function is not even. It's neither of them. This was all about how to identify if a function is even or if a function is what? Odd. The next topic that they touch based here in this section is evaluating piecewise function or a piecewise function. First, we have to know what is piecewise. Piecewise functions. Or a function, because a function. The functions that they are in the form of h of x equals f of x, and here another function g of x, we call this type of functions piecewise. The complete name is piecewise defined functions. In your book, they just named it piecewise functions. It's okay, it's piecewise functions. Correct? Now, if they give me a piecewise function, how I can graph a piecewise function, or how even first, how, because we are talking here about evaluating, how you can evaluate a piecewise function. Let me see if they have a good example here in your book, because the one that they put here, I don't like it. I don't want to put immediately decimals for you to make you confused. Let me find one from your homework. If they have one. Oh, for example, problem 54. Correct? Problem 54, 6.2. Uh, f of x equals 6x minus 1 f x is less than 0 and 7x plus 3 if x is greater equals 0. Before solving this problem, at which point they're asking you evaluate f of 4. Before I solve this problem for you, let me explain one of the main characteristics of the piecewise defined function is their domain is restricted, correct? The domain of these functions are restricted. How? Later, after I start graphing, you will see what does it mean, why the domain, how you can say the domain is restricted. For example, in this example, you see 6x minus 1 if x is less than 0. It means in this function, if this is 0, you have to take all the values that they are less than 0, not greater than 0. You see, somehow your domain, the values of x is your domain, right? It shouldn't be any more a question for you. We talk too much about domain. X less than 0, it means the domain is restricted here. Or in the other one, which is 7x plus 3, if x is greater equals 0. Again, the domain is restricted from 0 to where? For this one, your domain is actually a closed circle at 0 to the right, to the infinity. This one is an open circle and moving to the infinity. Why I explain this for you? Because when they're asking you to evaluate a piecewise function in a given point, you have to focus on the domain. Do you want to plug in 4 in the first function, or you want to plug 4 in the second function, or you want to plug it in both and calculate? That's the main question that you have to focus. A point is given to me. Should I plug it? Because you know, each one of them is a function. This one is a function, f of x equals 6x minus 1. This one is another function, f of x equals 7x plus 3. Should I plug 4 in one of them and both of them? Or if one of them, which one? Correct? If you can do this, if you can read this domain like this, which is this condition, some professors, they are calling it condition. Some professors, they are calling this restriction for the function. I think restriction is much better, correct? You have a restriction here. You have to see where 4 lies on the number line. Do you have 4 here from 0 to negative infinity? Definitely no. On the number line, 4 is not here. Oh, you have negative 4, but not 4. Definitely your 4 is on this domain from 0 to infinity, correct? Then if they ask you to evaluate f of 4, you should plug in a second function, which is f of x equals 7x plus 3. I used somehow green color, it's too light. Hopefully you can see it. I'll change it back to black. Did you see the reason why I choose the second function? Because the number that they are asking me to evaluate lies, or it's in the domain of the second function, not the first, right? Then I can easily here calculate f of 4. F of 4 equals 7 times 4 plus 3. You already learned how to evaluate a function. 7 times 4, 28, plus 3, which gives you what? 31. That's final answer. This is how you calculate a piecewise defined function. Not calculate, evaluate a piecewise defined function. Correct? There are more examples. Hopefully I assigned few problems for you. There are more on section 2.2 homework that you can practice with. Now, let's talk about graphing these piecewise defined functions, right? You can graph them too. You did it in the intermediate algebra. I'm sure those of you that you had intermediate algebra in high school or with Norco College, you already graphed piecewise defined functions. But anyway, maybe some of you, it was a long time ago. Let's go over it again, but quick. How to graph a piecewise function. There is nothing to explain here. I cannot give you a general form. I'll just copy an example from your book and I explain in that example how you can graph a piecewise function, right? Let's do one example or two. For example, you have f of x equals x plus 2 f. You see, for the piecewise, all of them has a restriction. F x is less than equal 1 and f of x equals 4 f x is greater than 1. They're asking you to graph them. Both of them are linear, right? These are the easy ones. Actually, I told you you are here dealing with two functions. The first one is this, f of x equals x plus 2, correct? How you can graph this? Please do not, those of you that you know math, do not use the y-intercept form of linear equations to graph. You may use, if you are too much careful, my recommendation is to graph piecewise defined functions using table, and I'll explain it why. Immediately choose a table of values for this function, x and y. Remember, with at chapter 1, when you are graphing a linear function or any function, when you're using a table, you are free to choose your input. Even I called it independent values. But when you are dealing here with piecewise, you are not that much free anymore because you have a restriction in your domain. What is the restriction here? Look, if you draw your number line, this is 0, this is 1. On 1, you have a closed circle, or if you want to use a bracket. Less than 1, sorry. I opened it that way. Less than 1. It means x can take all these values. From 1 to what? To negative infinity. Some professors, they're explaining this way to you, and I want to explain it that way also to you. Whatever the restriction is given to you, start with that number. Put that number first, 1. What is now less than 1? Focus here because you have x less than 1, right? What is the next number less than 1? 0. What is next? Negative 1. What is next? Negative 2. You can go all the way, correct? Now, everyone knows how to find the values of f of x, right? When x is 1, it means plug in here 1. 1 plus 2 gives you what? 3. When x is 0, 0 plus 2 gives you 2. When x is negative 1 plus 2 gives you 1. That's it. You are ready to graph this function. Let's graph it. Again, I'm using graphing. Hopefully, can I use this to this time graph much better? My hands are shaking. You see, it's much easier now. I'm also learning computer because of the COVID-19. A lot of new stuff in it. Yeah, really good graph. X and Y, and here is 0. Now, let's find our points. I'll calculate 2 cell as a 1, okay? 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, negative 5, maybe negative 6, and also here 1, negative 1, negative 2, negative 3, negative 4, negative 5. Usually I don't write numbers because, oh, if it's class, I can write, let me try. But here, if you put numbers, you will see a lot of stuff on one graph, 3, 4, 5, 6, negative 1, negative 2, negative 3, negative 4, negative 5, 1, 2, 3, 4, 5, and here, of course, negative 1, negative 2, negative 3, negative 4. Let's find our order pairs and graph it. When x is 1, y is 3. x1, y3. It means this point, right? x1, y3 is this point. When x is, oh, one thing. For the first point, when x is 1, y is 3. Look at here, you have x less than equal 0. Look at the domain, I used closed circle. For the first point, only first point, use a closed circle. Now, x0, y2, it means this point. X negative 1, y1 is this point. Then how to graph it? Your graph starts from here and goes all the way down like this. This is the graph of f of x equals x plus 2. Now, look at your second function. Your second function is this. Oh, let me use this time blue. Why my pens are like this? F of x equals 4. F of x equals 4. Which kind of line is this? Even you don't need a table. F of x equals 4. It means y equals c, right? Some topics in this book, they come faster because we discuss really in detail linear functions and 2.3, but we already start graphing here. They want to explain it to you. When you have y equals c, let me at least give you an idea. Y equal a constant number, you always have a horizontal line. You don't need to use a table. Just draw a horizontal line, but please focus on the restriction. X greater than 1. It means your line will start from here, 1 and 4, correct? I'll draw an open circle here, and greater than 1, I'll draw a horizontal line this way. Here you go. You graphed your piecewise define function, correct? If you need more examples, please come online Tuesday at 3. I'm online. It's my office hour. Come and ask me question. I will do it again for you, correct? Use my office hour. Last week, I think I had only one student online. It's every Tuesday at 3, correct? The last topic that we will cover in this section, very important topic in future, not now maybe for you, but in future you will see how important this is functions and difference quotient. Difference, use another capital here. Quotients. What is the difference quotient? The average rate of change of a function, oops, the difference quotient of a function is actually the average rate of change of a function in a given point, let's say, or you can say the difference quotient of a function is a ratio of the function at a given point. To be honest with you, this topic is one of the main topics in Calculus 1. Sir Isaac Newton, you may heard his name, Sir Isaac Newton, the great mathematician, the founder of calculus. He was thinking about average rate of a function. I'll give you a little bit idea. I don't want to talk about calculus here with you. I'll give you just a simple formula here. I don't want to talk about derivatives here, correct? But let me give you at least an idea when I'm talking average rate of a function, what does it mean, correct? You may be aware of this story of Sir Isaac Newton, even I'm not sure that this story is true or not. He was sitting, this is Sir Isaac Newton, if I can draw him very well. He was sitting under a tree and an apple falls down in his head, correct? Remember, maybe some of you are aware of this. It's all everywhere in the internet or people are talking about. No one is sure that this story is true. But the reason behind this story is if you have an object, any object, apple, stone, whatever is this, and it falls down, correct? Let's talk a little bit about physics, correct? It goes to the ground, right? Sir Isaac Newton knew very well on that time that with the simple formula of velocity, he cannot find the speed or the velocity of this object. For example, let's say after 5 seconds. After you drop something at 5 seconds, after 5 seconds, how much is the velocity? Correct? That idea actually encouraged him to create the new branch of mathematics. Thanks to him, that today, whatever you have in your life, whatever development you see in any field, and many fields, it's because of calculus. And he named it calculus. I don't want to explain calculus here. Average rate, velocity in physics, you know it's a function, correct? Even you know it right now. Velocity is a function. It's a function of time, right? He tried to find the average rate there, correct? That average rate here in your book, we call it difference quotient. I don't want to prove the formula here for you, correct? But the formula for the difference quotient is, if I name it dq, even in your book, they didn't name it, but you can name it dq, difference quotient, is equal f of x. Now, let me write in a nice way, because this is your main formula. F of x plus h minus f of x over h. We call this formula the difference quotient of a function. Now, if they give me any function, any type of functions, I can find the difference quotient of that function. Just remember it in this class as a difference quotient. When you go to chapter 2, calculus 1 class, hopefully some of you will go to that level. Immediately your professor will tell you, oh, let's talk about derivatives. And this is the main formula. If I put a little bit here limit also, that will be the main idea of derivatives. Right? But right now for you, difference quotient formula to find the difference quotient of any function. Let's do one or two examples for this, then I'll stop my lecture. Example number 1. Find the difference quotient of f of x equals 2x squared minus x plus 3. Let me bring the formula here. Difference quotient equals f of x plus h minus f of x over h. In your book, they put everything immediately in this formula. Don't do it. It will be a lot to calculate. Easily, you can do a mistake. Do it in 2 steps. Correct? How? Look at your formula. Please focus. In your formula, you have f of x plus h, and you have f of x. F of x is not a problem because you have it here. This is your f of x, right? 2x squared minus x plus 3. f of x plus h you don't have. You have to find what is f of x plus h. Not a big deal. You have f of x given to you. Can you find f of x plus h? We already did one example like this when I explained to you how to evaluate a function, correct? F of x plus h means on the right side, wherever that you have x, you have to replace it what? With x plus h. Then my right side will be 2 times x plus h squared minus, again, x plus h plus 3. Correct? Let's simplify our right side. Oh, you can plug immediately this to your function, but believe me, it will be a lot of work in one fraction and easily, even I do sometimes mistake, correct? Then let's simplify it here. F of x plus h equals 2 times x plus h squared, again, which method you want to FOIL it, you want to use a plus b squared, which method you can use it. It will be, the result will be x squared plus 2xh plus h squared, right? Minus, distribute the negative please here. That's why I used parentheses. Minus x minus h plus 3. Now distribute 2 here. Then f of x plus h equals 2x squared plus 4xh plus 2h squared minus x minus h plus 3. Do we have like terms? If we have like terms, let's simplify. Let's make it smaller. Do we have like terms? No, there is no like terms here, correct? No like terms. This one is x squared, this is xh, this is h squared, this is x, this is h, this is 3. That's it. This is actually my f of x plus h. After I find this, then it's easy to deal with this formula. Look, then the difference quotient, I will write here, I don't want to go here because it's less space there, I cannot work. Difference quotient equals, you need a long fraction bar. F of x plus h, here, f of x plus h means 2x squared plus 4xh plus 2h squared minus x minus h plus 3. Then you are done with f of x plus h. What is the sign in the formula? Minus. Be careful, minus. You have to open a parenthesis because you have a minus. F of x. What is your f of x? Look at this green. This is your f of x, right? 2x squared minus x plus 3 over h. Simplify. That's it. Difference quotient equals, again, a big fraction bar, 2x squared plus 4xh plus 2h squared minus x minus h plus 3. Distribute the negative. Minus 2x squared plus x plus 3 over h. Combine like terms in the top. Difference quotient equals. You have positive 2x squared here. You have negative 2x squared here. They become 0, correct? You have negative x. You have positive x cancels out. and you have positive 3 here, positive 3 here. It gives you positive what? 6. Am I right? Then write the rest here. What left? 4xh plus 2h squared minus h plus what? 6 over h. I think there is, here you see, I didn't distribute the negative. That's actually negative 3. Here you have a negative 3. I was thinking that this 3 should go away. Why still I have it? Here, when I distribute the negative, I distribute to this. To this, I didn't distribute yet. That's a negative 3. Then positive 3 and negative 3 also becomes 0. It means here, I will not get a 6. Now, I'm correct. You see how easily we can do a mistake. I did it. I did this mistake. I didn't focus. Now, what you can do here, can I take h in the top common or factor h in the top? Then I can write difference quotient equals, I'll take h as a common, 4x plus 2h minus 1. Am I right? Over h. H cancels out with h, then your difference quotient will be 4x plus 2h minus 1. This one is actually the average rate of change for the given function. I don't want to talk about what does it mean. I did a little bit when I explained. This is your final answer for this book, correct? This is how you calculate the different quotient of any given function. This was all about section 2.2. I'll stop the lecture here and see you all in section 2.3.